Hi everyone. Good morning, good morning, good morning everyone. Good afternoon, I mean, not good morning, good afternoon. Good afternoon everybody. Hello everyone, good afternoon, good afternoon. Very good afternoon. Hi Siri. Hello Russell, hi Navya, hi Rabia. Hello Ajay. Ajay, you were not present in yesterday's class. Hello Maheshwari, good afternoon. Hi Abhishek, good afternoon. Sir, is there any test tomorrow? Yes, there would be a test tomorrow. There would be a test tomorrow. Good afternoon, kids. How's everybody doing? I am good, I am good, I am good. Good afternoon, everyone. So, good afternoon, good afternoon, good afternoon, everybody. Hi, Satya, good afternoon. In chemistry, I know chemistry topics would be mole concept only. Whatever we have covered this week. Whatever we have covered this week, that would be the syllabus. And today also happens to be my last class, not the last gift class, but my last class with you. After this, some other new chapter would be starting. Some other teachers would come for that. So I think after this, you will be having, I think Birmani sir will come most probably. Okay. So topic will be changed, na? So today would be our last class, and I don't have to cover much. I only need to make you practice some examples on limiting reagent. So very much possible that we may be ending a bit early today because I just need to make you practice a few bits. Okay. Only this week's syllabus for all the subjects. That I am very sure about. For all the subjects, only this week's syllabus will be there. Okay, I'll miss you guys too. But don't worry, as soon as you are here, very soon we'll meet each other. Don't worry about that. Can we have some glands of what you said? What is glands? I am a chemistry teacher. Glands come in biology, I think. Significant figures we'll teach you. Ready, Anna? Once you are here, we'll teach you significant figures. Don't worry about that. Glands. Okay. All right. So shall we start? So yesterday, boys and girls, glance. Okay. So yes, you will get a glance. Classes will start sometime in May, beta. I'll miss you guys too very much. It has been an absolute pleasure, but let's save this for the last. Let's begin with the class first of all. So we were talking about limiting reagent. Okay. We were talking about the concept of limiting reagent, and I told you, yes, so let me give you a glance. I'm giving a glance only. So I told you that if a reaction is there, A plus B, revision of what we did in last class, not for the whole week, plus C plus dot goes to products. Okay. So whenever we discuss, boys and girls, that whenever the ratio of initial moles and the ratio of stoichiometric coefficients, whenever the ratio of initial moles and the ratio of stoichiometric coefficients, okay, are different, then what happens is that one of the reagents is consumed first. Okay. And the reagent that is consumed first, beta, that is known as the limiting reagent. The reagent that is consumed first, that is known as the limiting reagent. And we have to find the product. How many moles of product would be formed using limiting reagent only? Moles of product must be calculated using moles of limiting reagent only. So that is the very important thing which we discussed. Okay, so now over here, everybody pay attention. We have an exam tomorrow. Okay. So I told you that how to find out the limiting reagent. Your step one is calculate moles of A upon A, comma moles of B upon B, dot dot dot, like this. Everybody remembers this? All of you? So you calculate. Mangal Srinu is not present today, I think. Okay. And step two is, see, whatever topics you have slight misconception, all the recordings etc. are present on YouTube, so you can quickly watch the videos at increased speed. Just to get a recap and revision, you can watch the videos easily at an increased speed. So just make it 1.5, something like that, and whatever topics little bit you feel weak in, you can easily look at that. Okay. Now, okay everyone. So now, boys and girls, this is how we calculate, and what is our step two? The reagent having minimum value. The reagent having minimum value will be the LR. The reagent having minimum value will be the LR. And we should only use the moles of limiting reagent to form the product. I hope everybody remembers this. We should only use the moles of limiting reagent. Grandpa equation should be applied on the limiting reagent to find out the product. So are you ready to solve some problems? Are you ready to solve some problems, everybody? Everyone? Are you ready to solve some problems? Okay. Show some energy in the chat, everybody. Today is our last class. Last class with me. Once again, I am repeating, not last gift class, last class with me. So for the reaction, A plus 2B, I hope you will continue your good performance in today's class as well. A plus 2B goes to C. 5 mole of A and 8 mole of B, 5 mole of A and 8 mole of B will produce how much C? 5 mole of A and 8 mole of B will produce how much C? 5 mole of A and 8 mole of B. Are Mangal Sinu is back. 5 mole of A and 8 mole of B will produce how much C? Will produce how much? How much C will be produced? Will produce how much C? Yes, answer please everyone. Answer please everybody. Dikshita, how are you? Mangal Sinu actual name was Dikshita, na? 4 mole is absolutely correct. Well done, boys and girls. So what we'll do over here is, what is the reaction? Let's pay attention, everyone. Reaction is A plus 2B goes to C. Right? And we have 5 moles of A and 8 moles of B. 8 moles of B. Okay? So now this ratio 1:2. This ratio 5:8. So of course the ratios are different. Okay, bhai? Of course the ratios are different. So we will find out limiting reagent, moles of A upon A, 5/1. Moles of B upon B, 8/2. So who is smaller? Of course this is smaller. So B is the limiting reagent. B is the limiting reagent. So therefore how much C formed will be calculated by using grandpa on B and C. So grandpa on B and C will give me moles of B upon 2 is equals to moles of C upon 1. Moles of B upon 2 is equals to moles of C upon 1. So moles of B consumed is 8 upon 2 is equals to moles of C formed upon 1. So moles of C formed is how much? 4 mole is absolutely correct answer. Well done, very good, excellent, Jabardast, Shandar, Lajawab, mind blowing, amazing, fantastic, fantabulous. 4 mole is okay, everybody? All of you understood this, boys and girls? 4 moles. Okay, next problem. Chala baundi, yes, very good. Next problem. Next problem is (2H2) plus O2 goes to 2H2O. 4 gram H2 ignited with 4 gram O2. 4 gram H2 ignited with 4 gram O2. Find mass of water produced. Find mass of water produced. Find mass of water produced. 4 gram H2, this is 4, right? 4 gram H2 ignited with 4 gram O2, find mass of water produced. What is the mass of water produced? Tell me the answer fast. Mass of water produced. Mass of water produced. Mass of water produced. No. You have to give the approximate answer. Mass of water produced. 2 people have given the correct answer till now. Two people have given, now 4. Come on, everyone. Find the mass of water produced. .5 gram is absolutely correct. Very good. Well done, boys and girls. Excellent. 4.5 gram is absolutely correct. Very good. So, what is the reaction taking place over here? 2H2 plus O2 goes to 2H2O. Okay? Now, masses are given. H2 molar mass inni 2 gram per mole. So, moles of H2 is 2 mole. Given mass by molar mass. Given mass by molar mass. Molar mass of H2 how much? 2 gram per mole beta. So 4 by 2, that is 2 moles. And O2, what is the molar mass? O2 molar mass is 32. 32, right? So given mass by molar mass. 4 by 32. Given mass by molar mass 4 by 32. 4 by 32 is 1 upon 8 mole. First calculate moles of all the reactants. I told you in yesterday's class. So given mass upon molar mass of H2 2 gram per mole. So 4 by 2, 2. And given mass by molar mass, O2 molar mass 32. So 4 by 32, 1 by 8 mole. Now go for calculation of limiting reagent. So 2 by 2, 2 moles of A upon A. Moles of A upon A is 1. And moles of B upon B. that is 1 by 8. So of course, O2 is the limiting reagent. Of course, O2 is the limiting reagent. So product will be calculated. Okay, this is moles of A upon A. 2 by 2. 2 by 2, okay. Moles of B upon B. So this will become 1 by 8. Right? So obviously 1 by 8 is smaller than 1. Right? So O2 is the limiting reagent. So product will be calculated by applying grandpa equation on O2 and H2O. Grandpa equation on O2 and H2O. So what will you write? Moles of O2 upon 1, moles of O2 consumed upon 1 is equals to moles of H2O formed upon 2. Moles of H2O formed upon 2. And from here, I will get moles of O2 is how much? 1 by 8 mole. So 1 by 8 I will put. And 1 by 8 into 2. So moles of H2O formed will be 1 by 4 mole. Over here I have substituted 1 by 8. So 1 by 8 into 2. 1 by 8 into 2 is 1 by 4 mole. So 1 by 4 mole water produced. And mass of water, boys and girls, mass of water therefore will be equals to 1 upon 4 mole into molar mass of water. Molar mass of water in 18 gram per mole. 18 gram per mole. Mole cancel. Mole cancel. So this is 9 by 2 and 9 by 2 is 4.5 gram. That is your answer. So mass of water produced will be 4.5 gram. Is this understood, everybody? Is this understood, everyone? Yes, boys and girls. O2 is the limiting reagent. So 1 by 8 mole of O2 will give 1 by 4 mole of water. Chala baundi, yes. And then we calculated the mass of water produced, which is 4.5 gram. Next problem. Okay, pay attention, everybody. Next problem, boys and girls. .5 mole of H2SO4 is mixed with 0.2 mole of CaOH whole twice. Find moles of calcium sulfate produced. Find moles of calcium sulfate produced. Find moles of calcium sulfate produced. Do it, everyone, fast. Do it, boys and girls. Equation is not given. Molar mass is not needed over here, Janvi. Moles is given, na? Find moles of calcium sulfate produced. Molar mass not needed in this problem, beta. Moles is given. After this, we'll do one more question. Just give me 1 minute. You have to write the equation on your own this time. You have to write the equation on your own. Okay? So equation is acid plus base. Acid plus base gives you acid plus base gives you have you heard this? Arrhenius-Garu's equation, salt plus water, neutralization reaction. So H2SO4 plus CaOH whole twice, H2SO4 plus CaOH whole twice. So this will lose H plus, this will lose OH minus, 2H plus, 2OH minus. Sulfuric acid is a dibasic acid. So 2H plus, 2OH minus. So 2H plus and 2OH minus will give you 2 moles of water. And calcium and sulfate will give you salt. So you will have CaSO4. This is your reaction. And now, my dear kids, you have 0.5 mole of H2SO4 and 0.2 mole of CaOH whole twice. Who is the limiting reagent? Okay, 0.5 upon 1, 0.2 upon 1. So who is smaller? This is smaller, this is smaller, so this is the limiting reagent. This is the limiting reagent, and product should be calculated according to limiting reagent. So you can apply directly also 1:1. 1 mole will produce 1 mole, 2 will produce 2. So 0.2 will produce how much? 0.2 mole. So 0.2 mole is absolutely the correct answer. Yes, 0.2 mole is absolutely the correct answer. CaOH whole twice is the limiting reagent. Is this okay, everybody? Is this okay, everyone? Sometimes in problems, they may also ask you moles of excess reagent left. See, how did we define excess reagent? Excess reagent was that reagent which was left over. So they can ask how much left, okay? So whenever moles of excess reagent left is asked, you always do moles of excess reagent taken minus moles of excess reagent consumed. Okay, how much you have taken initially, and how much will be consumed, and how much is consumed, this will be calculated using the limiting reagent. Okay, so this will be calculated using the moles of limiting reagent. For example, first note down this, then I will add one more part to the previous problem. So in the previous problem, I am adding B part. Find moles of H2SO4 remaining. Find moles of H2SO4 remaining. Moles of H2SO4 remaining. So moles of H2SO4 that will be left or remaining will be taken. How much is taken? 0.5. 0.5 mole is taken. 0.5 mole is taken. Yes, very good. And how much is consumed? See, consumed will be calculated using limiting reagent. So here ratio is 1:1. With 1 mole, 1 consumed. So with 0.2, how much will be consumed? 0.2. Their consume ratio 1:1. So with 1 consumed. So with 0.2, how much consumed? 0.2. So 0.2 will be consumed. 0.2 mole will be consumed. Taken was 0.5 and consumed is 0.2. So how much is left? 0.3 mole. Very good, well done, excellent. 0.3 mole is left. Chalo, next problem. 0.3 mole is absolutely correct, bhai, everyone. Next problem, guys. 0.3 mole is absolutely correct. Well done. Next problem. Write down, bhai, everyone. 0.5 mole BaCl2 is mixed with 0.1 mole, 0.5 mole BaCl2 is mixed with 0.1 mole of Na3PO4. Find the maximum moles of Ba3PO4 whole twice. Find the maximum moles of Ba3PO4 whole twice produced. Find the maximum moles of Ba3PO4 whole twice produced. And reaction that is given to you is BaCl2 plus Na3PO4 goes to Ba3PO4 whole twice, Ba3PO4 whole twice plus NaCl. This is not balanced. So before solving it, first you are going to balance it. Before solving, first you will balance. Before solving, first you will balance. This is not balanced. This is not balanced. This is not balanced. Before solving, first you will balance. Arey bhai, 0.1 is wrong answer. This is not balanced. Balance the equation first, then solve it. First balance the equation, balance the equation. No, 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 no. Come on, come on, come on, boys and girls. Come on, everybody. Few people are started getting the correct answer. Few people have started getting the correct answer. .05 is very, 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 very correct. Well done, everyone, once again. Very good. So what will you do over here? You will balance the equation. 3 barium. So you will put a 3 over here. 2 phosphate. So you will put a 2 over here. Okay? And 3 2s are 6. 2 3s are 6. So 6 NaCl. Now this is balanced. Now, BaCl2Na how much? 0.5 mole. Na3PO4 how much? 0.1 mole. So, boys and girls, who is the limiting reagent? 0.5 moles of A upon A. 0.5 by 3. Moles of B upon B. 0.1 by 2. So this will be 0.1 something, 0.16, something like that. And this will be 0.05. So who is the limiting reagent? Sodium phosphate is the limiting reagent. This is your limiting reagent. So product will be calculated using moles of Na3PO4. 0.05 is absolutely correct. So you will apply Grant pi equation on sodium phosphate and this. So moles upon stoichiometric is equals to moles. Let us say this is X mole. Let's say this is X mole is equals to moles upon stoichiometric. Moles upon stoichiometric. Okay. So X is how much from here? 0.05 mole. 0.1 divided by 2. Are you able to perform this division? Everyone? Are you able to perform this division? 0.1 by 2. 0.1 divided by 2 will be 0.05. If you can do this much, then between you and a NEET seat, a seat in government medical college, only time is there. It's just a matter of time. Very good. This is all that is needed to crack NEET exam. Trust me on that. I'm not oversimplifying things for you. Anybody have interest to friends with me? Chalo bhai. Let's be friends with Rekha Shri. Rekha Shri is searching for some friends. Okay, 0.05 is clear, everyone. Okay, very good. Next problem. Next problem is a mixture of 1 mole Al and 3 mole Cl2 are allowed to react. A mixture of 1 mole Al and 3 mole Cl2 are allowed to react. What is the reaction? 2 Al solid plus 3 Cl2 gas goes to 2 AlCl3 solid. Find number 1 limiting reactant, number 2 moles of AlCl3 produced, number 3 moles of ER left unreacted. Moles of ER left unreacted. Moles of ER left unreacted. Moles sorry. Chalo, solve all the 3 parts. Al is limiting reagent. Absolutely correct. Al is limiting reagent is absolutely correct. Chalo, everybody do it. Everyone do it quickly, bhai. So let's start solving. First 2 parts are easy. Third one is also easy. 2 Al plus 3 Cl2 goes to 2 AlCl3. So this is 1 mole and this is 3 moles. 1 mole and 3 mole. Moles of A upon A, 1 by 2. Moles of B upon B, 3 by 3. So this is smaller. This is smaller. So Al is limiting reactant. Al is limiting reactant, part 1. Al is limiting reactant, part 1. Acha, how much AlCl3 will be produced? So AlCl3 produced, this is part 2, will be calculated by applying grandpa on Al and AlCl3. So grandpa on Al and AlCl3 gives me moles of Al. Moles of Al consumed upon 2 is equals to moles of AlCl3 formed upon 2. Moles of moles of aluminium upon 2 is equals to moles of AlCl3 upon 2. 2 cancel. So moles of AlCl3 produced is 1 mole. Because aluminium moles is how much? 1 mole. Aluminium mole is 1 mole. So AlCl3 produced will be 1 mole. First 2 parts are clear, everyone? First 2 parts are clear, everyone? Okay, now third part, yes. हाँ, तो they are solid, so what? I am not applying Avogadro's hypothesis. I am not doing in terms of volume, beta. In terms of mole, it does not matter whether it is solid, liquid or gas. When I am doing for volume, then we have to look for gas. Then we have to look for gas. So third part is how much of excess reagent is left. What is the answer for that? Excess reagent left 0. तब फिर why are you calling it excess reagent? Some part, अरे 0 cannot be the answer यार. Moles of ER left, तो some moles will be left ना यार, कैसी बात कर रहे हो? If 0 is the answer, then why are you calling it excess reagent? अगर 0 ही आंसर देना है, then why are you calling it excess reagent? How many moles of Cl2 is left unreacted? How many moles of Cl2 is left unreacted? How many moles of Cl2 is left unreacted? .5 mole is absolutely correct. Well done. 1.5 mole is absolutely correct. Very good, everyone. 1.5 is absolutely correct. How will we do this? 2Al plus 3Cl2 goes to 2AlCl3. Pay attention, everyone. 1.5 mole is absolutely correct. Initially, you had taken 1 mole of Al and 3 mole of Cl2. Now, who is the limiting reagent? Who is the limiting reagent? Who is the limiting reagent? Aluminium. And Cl2 is the excess reagent. Now, 3 mole Cl2, this is your taken. 3 mole Cl2, this is your taken initially. Now, how much will be consumed? That will be calculated using the limiting reagent. That will be calculated using the limiting reagent. Apply grandpa on Al and Cl2. Dekho, aluminium is the limiting reagent. So 1 mole aluminium will be consumed. 1 mole aluminium will be consumed. If 1 mole aluminium consumed, then how much Cl2 consumed? Don't say 3 mole. 3 mole to you have taken, na? That is the excess reagent, na beta? So if 1 mole aluminium consumed, then how much Cl2 consumed? So for that you will do moles of Al. Moles of Al consumed upon 2 is equals to moles of Cl2 consumed upon 3. Dekho, this will be consumed total. If 1 mole of this consumed, then how much Cl2 consumed? For that, I am applying grandpa on aluminium and chlorine. 3 mole chlorine I have taken, but chlorine excess reagent. 3 mole will not be consumed. Ipo leda. This is ipo in the 1 mole finish. This is 3 mole, some left. So how much consumed? That will be calculated by applying grandpa on Al and Cl2. So moles of Al consumed upon 2 is equals to moles of Cl2 consumed upon 3. And boys and girls, how many moles of Al is consumed? How many moles of Al is consumed? Al consumed is, sorry, Al consumed is 1 mole. So in place of moles of Al, substitute 1. Substitute 1 mole over here, right? So once you substitute 1 mole over here, you will get moles of Cl2. Moles of Cl2, that is what? Consumed. Okay? So this 1 mole Al will be totally hypo in the finish. So put 1 over here. Once you put 1 over here, you get 3 by 2. That is 1.5 mole. 1.5 mole. So initially you had taken 3 mole. Initially you had taken 3 mole, 1.5 mole consumed. So moles of Cl2 left or remaining is 1.5 mole. That is 3 mole minus 1.5 mole which is equals to 1.5 mole. This is your answer. Is this okay, bhai? So how much of the excess reagent is consumed? This you will calculate by applying grandpa. So sir, with this knowledge, can I write the exam for fun and get selected? Means which exam are you talking about? NEET? No, you cannot write with this knowledge. Yes, but you can write with this mindset. I was talking about your mindset, not about your knowledge level. Is this fine, everybody? Give some questions from mole concept Y map. Okay. Chalo on, do this from Y map. 5.6 liter of O2 at NTP contains how many atoms? Do this. 5.6 liter of O2 at NTP contains how many atoms? Last question for today. Two volume. Satya Teja, I'm sorry, I did not understand your question, beta. How many atoms are present? So first what you will do is that you will calculate moles of O2 over here. Moles of O2 will be given volume by molar volume. So that is 5.6 upon 22.4. So that is 1 by 4 mole. So number of atoms would be 1 by 4 moles into 6.02 into 10 to the power 23 number of molecules, and every molecule has 2 atoms. So this cancels this 2 times, and now your answer is 3.01 into 10 to the power 23 atoms. See, they are asking in 5.6 liter of O2 how many atoms are there. So we will do given volume by molar volume. Given volume by molar volume will give us the number of moles. Number of moles into Na. Number of molecules, and every molecule has 2 atoms. So into 2 we will do. So solving this I will get 3.01 into 10 to the power 23. Yes. Okay, bhai, everyone. 3.01 into 10 to the power 23. All right, guys. So that will be all for today. And you all have been fantastic. I'm really impressed and happy to see the kind of students that are going to come to Sri Gosalites in the next academic session. That is the current academic session, which will begin as soon as NEET exam is conducted. And really happy, really eager, waiting for each one of you to come over here, and finally I'll get a chance to meet you in person. So far you just know me, but I have to know you more. Okay, so really happy. You all have been very fantastic, and just keep this enthusiasm, just keep this momentum going. And if you are able to handle, because at no point of time while teaching, I had the feeling that I am teaching kids who are still officially in class 10. I mean, officially they have not come in class 11. So the way you have been responding, whether it was in chats or whether it was in calculating the questions, that was fantastic. I was really impressed, really very happy, and I wish you all the best. Okay, so I'm sure that you have a very bright future, and it's just a matter of time when you can start calling yourself doctors. Because if you are able to handle numbers of this type of mole concept calculations and things, then trust me, rest of the physical chemistry will naturally come to you. Okay. Okay, bye bye guys. I'll miss you all too. I'll miss you all too. Okay, take care everyone. Sir, you changed your glasses? Yes, 2 days ago. And when college starts, I think sometime in May, I'm not sure about the date. I'll miss you all too. Come soon, come soon. We'll meet over here. Take care, bye bye, have a great time. Bye, 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 bye everyone. Bye guys, bye, bye. I'll miss you all. Thank you, thank you.